Okay, in the previous class, we learned about our human civilization start with the material. We have the Stone Age, and then we go to the Bronze Age. Not Bronze Age. Yelah, Bronze Age lah. Bronze Age, and then we go to the Iron Age. Okay, during the Stone Age, people use what? We have discussed before. People use stone, bone, and wood. The problem with this thing is that even though stone is hard, wood is okay, but then they are susceptible for what we call splinters, snap or crack. For example, I have this wood, the popsicle, popsicle stick, and then it just simply snap like this. Okay, so metal are fundamentally different because if you look here, these things are both are metal. Metal are fundamentally different because you can hammer it into shape. Okay, you can hammer it into shape. So I have this thing. Let's do literally. You can hammer anything into shape using metal. For example, if I do like this, you can hammer it, making it dent, or I can do like this, like that. Okay, you cannot do this for stone, bone, or wood. Okay, that's one thing about the metal. You can hammer it into shape. So this is one of the properties of metal. You can say you can hammer it into shape. Okay, so meaning that what does it mean is that the metal is malleable. So that's the properties lah. Metal is malleable. It can flow, sort of. It can flow. It can flow like that lah. It can flow like that. And also, in fact, when you hammer something, when you hammer the metal, you can make it stronger. If you have a blade, a sword or whatever, if you hammer it, you make it stronger, even stronger. And you can reverse this process. You can hammer, you can also make it stronger. Make it stronger by hammering. And you can reverse the entire process by just throwing the metal into the fire. You can just reverse the process. Reverse the process by putting thing into the fire, putting metal into the fire, and then you can get soft thing lah. You can get soft metal. You can get soft metal. So now on your hand, you have something that is as hard as rock, stone, but then it also have the properties of malleability, like plastic. You have something that is hard as stone, but also plastic at the same time. So that is metal lah, one of the unique properties of the metal. And bronze here is an alloy. We learned in the previous class, bronze is alloy of what? Bronze is alloy of what? Copper plastine. Copper plastine. Okay, copper plastine. So that is bronze. And iron is the element. Iron is the element. Element. In fact, the only element that is named after the age is iron lah. And in fact, people argue that nowadays also we are still in iron age because the iron is so ubiquitous in daily life. But of course, we don't use iron, we use steel lah. Steel, the bulk of it is made of iron. We will talk about that later. But before that, let me open the periodic table. As usual, I don't have slides, so I use Google. Let me open the periodic table first. Periodic table. Not internet. Let me open the internet first. Okay, wait for it. Sudah. Ini saya tak suka ni. Traffic light. Tengah. Sini, verify. Okay. PT table. Okay. So for Howlett, this is normally the basis lah. I mean, we use this most lah. When you try to study material, this is at least the what we call the staple food for you lah. To digest. This is like the building block of all material, and most of this on the periodic table is made from metal. Why is this goes down? Oh yeah, like that. Okay. So the iron is here. Where is iron? It's here. Iron is there. Okay. So we talked before how people, in the last class, we talked before how people get this metal in the first place, basically from the iron ore, metal ore lah, from the metal ore. So what they did is that this metal ore is just like a natural stone that have the metal oxide on it. That's what the definition of metal ore. Any natural rock that have a metal oxide on that. And then you smelt it, you go into the process called smelting. So smelting, during smelting, you need to create fire lah. Smelting is basically to put this thing into fire lah. So during smelting, you add what? You add the charcoal, the fuel lah, the fuel. So the fuel, normally people use charcoal lah, charcoal. Any carbon-based thing. So charcoal will sort of like, this charcoal is carbon source. So basically when smelting happen, the charcoal, the carbon source, this carbon source will create the carbon monoxide, and then this carbon monoxide, let's say in terms of iron, you combine with the ferrum oxide, ferrum to oxide, because what we call? Because in metal readily oxidize. Some metal lah, certain metal does have low oxidation rate, like gold. Gold is also metal, but it's have very low oxidation rate. But metal like iron readily oxidize. So you get this what we call iron oxide. Iron oxide. So the purpose of this, what we call, to extract the metal from the ore, you need to what we call, to burn this thing, burn the rock using charcoal, meaning that in order to create the fuel. This charcoal, the function is that is to extract the oxide, the oxygen there lah. So you get what? What you get after that? You get CO2. You get CO2 plus ferrum, right? You get 3 CO2 because you have 3 CO. See, so there are 3 here. 3, 6. So 3, 6, and then you have ferrum, 2 ferrum lah. Ferrum oxide like that. Is it correct? Is it correct or not? I don't know. Is it correct? Yeah, that's correct. Okay. So basically, by using this smelting method, you basically extract this ferrum out of the ferrum oxide. This is ferrum oxide. So you extract the ferrum out of ferrum oxide. So you get the ferrum there. So this is the way how your Ancaster extract the metal from the rock and so on. Okay, because most of the metal, the iron that we got, that we use nowadays here, this metal here, they are the origin for this. All these things is mostly from the rock lah. From the rock. I mean, they extract the metal from the rock. Okay. So that's one thing. So let's talk about the iron a little bit, because we have dealt with the bronze before, copper and tin, and we tell before why people goes for the iron. And then now today we talk about the iron a little bit. Okay. So for the iron by itself is not so useful lah. By itself is not so useful because iron is quite soft actually. The pure iron, not the steel. This is not iron. This is steel. What you see here, this thing, this is steel. This is not iron. This is steel. Okay, the iron by itself is quite soft. Quite soft. So people want to make it stronger. Okay. So how they do it? They basically add with the carbon. So how to make iron stronger? So how to make iron stronger is basically you add with carbon lah, with carbon. So they are, for example, if you put a little less, for example, like 0.05% into 0.3% like that, they call it, they have name for that. They call it mild steel. Mild steel. Previously, they call it as wrought iron. So I just write this first and then I explain. And then this is carbon content. This is carbon content. Let me put here. This is carbon content. This is carbon content. Let me put here. This is carbon content. This is the name that they give. So this is carbon content. And then if let's say the amount is around like 1%, roughly lah, 1% into to 2%, they call it what? They call it what? Huh? They call it what? Siapa buat metal? Siapa buat metal? Hai tu. Who present about metal? Siapa? Who present about metal before? Oh, semua tak mengaku. Ha. Amirul. Bukan, seorang lagi perempuan. Sister siapa? Rauda. Rauda cannot come. Okay. When you have the metal, the carbon content in the metal is about, this is carbon content. So this is carbon content, I put here, carbon content. So meaning that you are basically adding the carbon into the iron lah. So if the carbon is 1 to 2%, we call it steel lah. Standard steel lah, steel. And then if the amount is around 4%, 2% to 4% like that, we call it cast iron. Cast iron. Okay, so that is a definition lah, some definition. But before we talk about this, we need to talk a little bit why we put carbon. Why we put carbon after all? What is the purpose of putting carbon after all? Okay, the idea is that why we put carbon is that metal by itself, okay, I put here. So this we go a little bit fundamental. Metal by itself is a crystal. It's made up of the crystal. Made up of crystal. Okay, so metal is made up of crystal. Typically, when we talk about crystal, we think about something like this, right? Shiny, shiny, transparent, blah, blah, like that, right? So if you look at crystal, you see there are facet. We call facet, meaning that side that is very smooth in one direction like that. So you can see a lot of facet on this crystal. Okay, so when we talk about crystal, typically people think about this. We don't see metal crystal like that because first, metal crystal for first is opaque. It's opaque. And secondly is incredibly small. It's microscopically small. Microscopically small. So that's why you don't see the metal crystal like that. The definition of the crystal itself, okay? The definition of the crystal itself, okay? What is crystal? What is crystal actually? If I ask you the definition of crystal, what is definition of crystal? Anyone? 0.5. 0.5, Mark. 0.5. What is definition of crystal? Definition of crystal. Solid compound. Ni pun solid compound. Dinding pun solid compound. So it's not really definition of crystal like that. Because foam, for example, like plastic. Plastic is not really crystalline now. Plastic also solid. We see solid. This also solid. But we don't call it crystal. So it's not really accurate that. So anyone else? When we talk about something like this, what make this crystal have this very sharp edge? There are reasons why the crystal behave like this. They have very sharp edge. What is the reason for that? Alright, any idea? You can understand me, right? Is it I talking too fast, too slow? Is it okay? Okay. Anissa, why this crystal have? Let me open lah. Tak boleh ni. Patah pula punya. Ni, why this crystal? They don't. This occur naturally. Diamond that you see, diamond something like this. That's not natural. Diamond, if you go and dig under the earth, the diamond is something just like a rock. So that people make a diamond because they cut it. You might ask why, how they cut it. Diamond is very hard, right? But that's another story lah. But diamond, they cut like this because the people cut it. The reason why people cut diamonds in such a way because diamond have high refractive index. Okay, the reason why people cut this instead of using this block of stone like this, diamond also, why people do this is because of diamond have high refractive index. What does it mean by refractive? Meaning that refractive meaning that the light will bend. if you have something like this, and then if let's say this is glass, and then I have, oh, jauh lah pula. If there is glass, you can see also. Holland, can you see? Can you see? Can you see here or not? It's okay. If you cannot see, just watch the recording. Okay. So the glass here, let's say this glass. Okay. Let's say this glass. I want to talk about this refractive. Refractive meaning that if you have light, there are too many things like this diamond here. When you have light here, glass will bend. This thing. Okay. The bend. Diamond have the ability to bend farther than glass. Glass, the refractive index Ri is around 1.33. Diamond, if let's say I have diamond here, let's say I have a diamond here. This is diamond here. Diamond, the refractive index, if I'm not mistaken, is around 2.42. Refractive index is around 2.42. So when this happens, when you shine the light here, oh, this is not right, because when you shine the light perpendicularly, they will not, what we call, the light path will not be refracted. Okay, because I don't know whether you study this in your physics or not, in your school physics or not. Because for the refractive index, there are law for that. For example, the Snell law. Have you hear about this before? Yeah. Benda tu. Snell law. You have Snell law. Okay. Snell law state that n1 sine theta 1 equal to n2 sine theta 2. What does it mean is that if the theta is 0, when you try to shine the light perpendicularly to other medium, because refraction happen when the light travel into the different medium, if your theta is 0, let's say this is the light. So this is the light, and then when this oblique is not perpendicularly, and then this will sort of like refract. So this, we call this, the theta there is basically, if we make a plane here, I don't know whether you can see or not, I don't know, you can see? So this thing, theta 1, this is theta 2 lah. So if theta is 0, if let's say theta is 90%, if theta is 90%, let's say I put, I don't know where is to put there. Penuh dah. So if the theta is 0, let's say this, if the theta is, if let's say I put this light like this, and then the angle is 90%, if the theta equal 90%, there will be no diffraction. So this will go straight. You can try this lah, using the, what you call, water, take a laser, whatever, you can try lah. Because why? Because sine 90 is basically 0. So when it's 0, 0, 0, everything is 0 lah. 0, 0, 0. So there are no diffraction lah. So that's why refraction only occur at the side angle. That's why when you see the diamond, they cut it in such a perfect, the certain angle. They not do it like straight like this. They put a certain angle in order to get this the refraction to happen. Because when refraction happen, the light will go there and just reflected inside and go here, reflected inside, and then that's why you see diamond brilliance. You can see the shiny apa nama? Lelap apa? Lelap. Not glitter. Yelah glitter, boleh lah. Lelap like that lah. Because of this refractive index. So diamond, when you do like this, is much more pronounced lah. I don't know how to draw it, but it's much more pronounced than this lah. Because refractive index is very high. Okay, why I talk about this? Just to show you that the diamond naturally is like this. This is unnatural, it's synthetic. People create it. This is different. This now is material science. That is not material science. That is physics. So this is happen naturally. When you see stone, when you go near the college ke whatever jalan-jalan ke, you will see stone like just a block like this, right? But this crystal, they have a not specific. I mean that quartz or whatever, they have this sharp edge, very particular edge, very clean and sharp edge, because That's occur naturally because the atom, when you have something like that, so for example, let's say this is crystal. This is crystal. What actually you see is basically, if you can have a very strong microscope, the atom here is basically arranged very periodically. We call it atom is arranged in periodic manner in crystal. It's like when you are palapis, when you are like a soldier or whatever, you know, soldier they have this arrangement, the very specific arrangement. Apa nama dia? So soldier they have very what you call structured arrangement lah. So that's what happened here. The atom itself arranged in a periodic manner along the side here, okay, along the side here. So that's the definition of crystal lah, where the atom inside anything that is what you call arranged in such periodic manner, such arranged or defined manner, then we call it is a crystal lah. Usually in any object, you see the atom not like this. The atom normally, when you see in any object, any normal object like wood or whatever, the atom just haywire here. There are no specific arrangement. So the crystal, what define the crystal is that they have like specific arrangement like that. Okay. So we can rub this thing because this is not really useful for material, but at least you know a little bit about diamond. Okay, I put here. So in metal, what make metal fundamentally different than other material is that metal is made up of the crystal, tiny crystal. One crystal in the metal is like this. Let's say you have this crystal, and then you have the atom arranged like this. Banyaknya nak buat ni. Penat dah ni. Itulah, copy paste. Ya. But if I don't do like this, then it's not nice lah. I mean, it's not complete. So let me complete lah. Why I draw very big? But you can see now, the atom is arranged in one specific orientation. So this atom is periodically arranged in a tiny crystal. Okay, so we call this also as a grain. So imagine now there are. So this thing I'll make a 3D. So this is one crystal of metal. In, for example, in a knife, whatever, if you see a knife, if you see the knife, you have metal. So inside this, you have billions of these things. So you have something like this, 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 something like this. So it's not like the entire block of this thing make a metal. It's like the combination of many of these make a metal. That thing, this thing, you can, this meaning that it's very crystalline. We call it crystalline because you can see to the naked eyes, from the atomic perspective, this is a lot of atom, but the atom is arranged very periodically in the very long distance lah. For you, maybe it's just 1 centimeter, but for atom, this is a long distance. Okay, so that's crystal. But for atom, they have also like that, but it's very tiny, microscopic small, and also it's opaque. That's why you cannot see the like that lah. But here you can see you have something like this, something like this. So this is what we call grain lah, grain. So if I look at the picture under the microscope, let me go here, and then how to what to write metal, grain, SEM. SEM is one of the name of microscope lah, electron microscope. Okay, so you can see that thing. Let me image. Cepatlah. Okay, so you can see that thing. So that is tiny crystal. If you look metal under the electron microscope, because if you use a normal microscope, you cannot see lah. You can maybe see some, but you cannot see the atom lah. But here, you can see here. They are what we call crystal. But there are many of them. Okay. So when you try to saya ada knife tak? Saya tak ada knife. Tak bahaya bawa knife. Okay, when you have knife, or when you have a razor to shave, the razor become dull over time because of this thing, they collide with each other. When this thing, for example, you have razor, right? Macam mana bentuk razor? Whatever lah. Gillette. I hope you know. You know this thing? What is this? Razor. You have seen that before, right? Okay. Because I don't know the thing. Okay, this thing over time, this color. This thing over time will be blunt because of what we call, because of this, the collision of this, what we call crystal, collision of crystal with your hair lah, with your hair. So this thing will be rotate and breaking the bond and so on. So that's why over time it will be dull. Okay, because of this tiny crystal inside this thing. And if you try to look further inside this crystal, inside this one crystal, you will find this is in metal not in other what we call in other material, only in metal You will see a dislocation. You will see some squiggly line like this, something like this. If you look closer enough, you will see something like this. But before that, let me show you first metal atom. Metal atom first, before I show you that thing, squiggly line. Metal atom. TEM. So you can see this is metal atom. It's a metal atom. You can see the atom using the electron microscope. So you can see one of the properties of metal is that the atom inside the metal is arranged very orderly manner. One other word for this is orderly. Periodic or orderly. It's arranged in very orderly manner lah. So that is metal. You cannot find this in polymer and so on. Okay, so that's one property. But along this grain, whatever we call this grain or crystal, there are also this black line, we call it dislocation. This black line, we call it dislocation. Dislocation is basically the, what we call, the disturbance in the atom itself. If let's say you have the atom like this, this atom, and then you have another atom like this, and then suddenly you have another atom like this, and suddenly they go like that. So they have something like this. Okay, so they are, you can see there are some sort of like dislocation. Instead of going straight, they are going to the side, and then there are another atom here. So this is what we call dislocation. So if I just put here metal atom, dislocation. So like this lah, like this. Yeah, this thing. So that's dislocation. Let me make it bigger. So you can see here, from the top you have 1, 2, 3, 4, 5, 6, 7. By right, if you want to make something crystalline, 1, 2, 3, 4, 5, 6, 7 on the top. On the bottom also you need to have also 7. So to make thing order. But dislocation happen like this. In the middle here, suddenly there are atoms missing. So you have 1, 2, 3, 4, 5, 6 instead of 7. So that's create dislocation. Under the microscope, you will see this as a what we call as a black line. So let me put metal atom dislocation, TEM. Do you have that thing? Dislocation. Like that. Like this thing. Let me open, make it bigger. Tak bigger pun, macam tu je. But you can see lah the idea. So that is basically one crystal atom, but they have dislocation. Okay, so you see this dislocation thing. Dislocation, the term itself sound bad, right? Because the atom doesn't perfectly in order. By definition, the word dislocation means something bad when the atom doesn't be in their crystal formation. But it turns out dislocation is what make you can bend this thing. You can bend this thing is because of dislocation. The dislocation is what make metal unique. You can bend like this. You can have paperclip bend. I have paperclip or not? I think I have. Banyak barang. Paperclip, you can bend like this. Because when you bend, actually what you do is that you are moving an atom from one side to another side through the dislocation path. Because the dislocation is basically the what we call the disturbance in the arrangement of the atom. So when you bend like this, what are you doing actually? You are moving one atom to another part through this dislocation path. I mean roughly there, because dislocation had, because in one single crystal there can be many dislocation. So that's why you can bend here like this, like this. Okay. You cannot do this for wood. For plastic is different. Plastic a little bit different. Plastic normally when you do like this, they will coming back to the original or whatever lah. But that's not dislocation, more or less. That's something else. But the metal, the reason why you can bend this thing is because of the existence of the dislocation. Okay. So now, coming back to this, why we add carbon? Why we add carbon? The reason why we add carbon to the iron, as I said, iron is sort of like very soft, a little bit relatively soft metal. So when you add carbon, you basically you sort of like the alloy or the carbon atom, you put the atom carbon around here, inside the lattice. We call it this lattice lah. This thing we call it lattice. Lattice is basically apa? You know lattice? Lattice tahu? Tahu lattice apa? Lattice ni, saya tak tahu lah apa maksud dia lattice. What does it mean by lattice? Lattice is, benda ni lattice ni. Lattice atom. Ni, atomic lattice refer to blah 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 arrangement of atom in a crystal structure, meaning that that lah, arrangement of atom in the crystal structure. So meaning that this atom in this crystal, the arrangement is like this. So that's we call atomic lattice lah. So when we put something in the atomic lattice, we sort of disrupt the dislocation and so on lah. So when you put something carbon atom, let's say this is iron, this black one, this blue one is iron. Let's say we put it this one is, let's say this is iron atom. The blue dot is iron. Then the green dot, we put this thing, the green dot. The green is carbon. The blue dot is iron. Okay, when you put the carbon inside this thing, a few percent of carbon here, what this carbon does is basically it prevent the dislocation from happening, making the metal stronger, because metal is malleable like this because the dislocation. If you can put something in the middle of the lattice of iron, then you disrupt the dislocation. You somehow arrest the dislocation from happening. So that's why alloy is stronger than pure element lah, because this is the concept of alloy. Alloy is basically the art of preventing the dislocation. People say alloy, making an alloy, combine the metal together, is an art to prevent the dislocation from happening. So when you prevent this, you get something strong lah. But you see here, so here you put around very less carbon, 0.05 to 0.3% carbon into the iron. So you get what we call a mild steel or raw iron. Okay, if you put 1 into 2%, you get steel, normal steel lah. But if you put too much, let's say this, you put too much of carbon atom, what will happen? It become too strong to the point that it will become brittle, because something that is too strong typically it brittle, not too strong. When you put a lot of thing, mean that you prevent most of the dislocation from happen. So the thing, when it break, it snap. Instead of breaking like this, it just break like that. Instead of ductile, become ductile like this. This is what we call ductile. This is what we call brittle lah. Brittle. So if you put a lot of carbon atom in the lattice, what will happen is too much, it cannot bend anymore to the point that it just snap when it reach the failure point lah. So this basically brittle lah. So this is what the problem with the cast iron. Okay, the cast iron normally you can see, I don't know, normally what you see in your kitchen nowadays is this steel, stainless steel. We will go to stainless steel later on, but it's basically coming from the steel. The cast iron normally, if you have in the kitchen something that is heavy, something like a pot that is so heavy, so let me put here, cast iron, let me put Canon lah. This normally Canon, they make, so this thing, so this is what we call the cast iron lah. They make from the cast iron, this thing. The old Canon, they make from the cast iron. Okay. Long time ago lah they use this, but over time they don't use this anymore because this thing is brittle. They cannot sustain they're strong, but they are hard, but when they crack just like that, crack explosively. So this is example of the cast iron, cast iron in the kitchen, because if I show you a Canon, you don't see. So this cast iron in the kitchen, normally you see something that is heavy, the pan that is heavy, so that's basically cast iron lah. This thing from cast iron, this not lah, this not. This thing lah, something that is heavy, something that is very thick, so that is cast iron. So cast iron have like 2 to 4% of ni lah. But for the engineering usage, people use steel. People don't use this because it's too brittle. If you make the bridge using cast iron, then if there is any what we call any failure, then they just break, snap like that. So they use steel because steel, at least if the load is higher than what the bridge is intended to, at least the bridge will be sort of like go down like this, become a little bit ductile. So it's not like snap like that straight away. So people use steel. Okay. So this is 1 to 2% steel, and then if you have like a very low amount of carbon, we call it mild steel. So mild steel also we don't use it in engineering. So this is what commonly used lah in engineering engineering field. Okay. So now this is alloy. Alloy. When you add something to the metal, you get normally metal, add metal, you get alloy. Okay, so now how they put this? So the question now, how they put this carbon? How they put this carbon to the iron? Okay, when you do smelting, you get ferrum. You get the iron lah. You get the iron. This carbon monoxide, ferrum oxide, and then the carbon monoxide will take out the oxygen. And then you get the iron. The problem with the smelting of the iron is that this is not the full story. This thing, ferrum here, the iron here, they have something special about the iron is that they will capture the carbon also. In reality, this is the equation lah. But in reality, the iron will bind with some carbon lah, some carbon also. So normally the carbon will bind, not bind, mean like this lah, will enter the the iron lattice. Okay, so this what happen when you smell iron. This doesn't happen for copper, doesn't happen for tin or whatever, but it happened for the carbon. Not carbon, it's happened for iron lah. The carbon that is released, the carbon from the carbon monoxide somehow goes inside into the iron lattice. So when the people during the Iron Age do the smelting, actually what they create is basically is not pure iron. They already extract some of the steel, because when you carbon plus iron plus carbon, you get steel. You get steel. So this thing. So when you do this thing, you don't get only iron. In reality, you already get the steel, because some of the carbon here will somehow goes into the iron lattice lah. So that's why people can use this during Iron Age. People can use their tools to the tools that is made from this Iron Age is strong. It's not like very weak, because it's actually in reality they already create this steel. Okay. One of the problem with this, you cannot control how much carbon to be put into the into the iron, because as you can see, if you put at different range, you get a different steel. This is steel lah. This steel. Okay. If you put carbon at different range, you get different type of steel. The early civilization, they don't know. What they do is that they just do try and error until they find that the steel that they got is so good, then it's fine lah. And then they pass the knowledge to the new generation and so on. Okay, so that's what happened during this age lah. They just transfer the knowledge of smelting and so on, so that they get a right proportion of this iron. But nowadays, we can sort of like dictate how much we want to put. Okay, so how we put it, because it's difficult to sort of like to precisely dictate how much carbon will go to here. So what they do is that, so I can this okay. So I can just close this thing. Okay. So what they do is basically, because they know this thing is not pure iron yet, they have something thing. So let's say I put here lah, 3CO plus Fe 3O2 equal to 3CO2 plus 2 Fe. Okay, this part, when they smelting, let me put this thing. When they do smelting, they already molten the iron. What they get is basically this thing. You get apa color ni? You get this molten iron lah, molten iron with some impurities, because this iron is not pure lah. Molten iron with some impurities. Originally, you have what we call, you have this. Let's say I put here. You have the ore with some iron oxide, ore with iron oxide, and then to extract the oxide out, you do smelting. Smelting basically to remove the oxide, and to melt lah, so that you can extract the iron. Okay, until here is fine. What you get here, if this thing cool down, you get an iron with some impurities, because there are some impurities in this molten iron. So what they did is that in order to what we call, they can get, for example here inside this molten iron, maybe in one batch they got like 2% carbon inside that. In another batch, when they repeat again, maybe they got 3%. And then another batch, they repeat again, maybe they got 1%. So it's not consistent when they do like this. So the way how steel become the industrial material is that because of one process called Bessemer process. Bessemer is the name of the one British guy. Bessemer process. What Bessemer did is that from this molten iron, what they did is that they put this molten iron inside this furnace, something furnace like this. The molten iron inside this furnace, they put the molten iron inside this furnace. So this molten iron with impurities lah, with impurities. And impurities typically here, the impurities that typically occur from, that they found from this molten iron is carbon, because we want to remove carbon, like carbon, and then silica, because they extract all of these things from the rock, and rock is basically sand, right? Sand is silica oxide, and then some magnesium and so on. So they want to remove this carbon, silica, magnesium inside this. So imagine now here inside this there are impurities like carbon here, carbon, and then magnesium, and then silicon here. So this molten iron, so what they do is that they jet the oxygen inside this thing. So the oxygen will bind with all these things. The oxygen will bind with carbon, become carbon dioxide. The oxygen will bind with the silicon, become silicon oxide and magnesium oxide. Silicon oxide and magnesium oxide is a solid. So it become like, it will dense, it will go down lah. Carbon dioxide is gas. So carbon dioxide there, carbon dioxide will go out as a carbon dioxide. So carbon will react with the oxygen, you get carbon dioxide here. And then this silicon and magnesium will react with the oxygen, will combine with the oxygen, you get silicon oxide and magnesium oxide. And these two things is a solid, so it's dense, so it goes down. And then here they are what we call, there are two holes here, they are basically hole here, and also there are hole here. So this, the one that is dense, they, for example, silicon oxide or magnesium oxide, they throw it here. And then this is the pure molten iron. Pure molten iron without nothing. So this is pure molten iron. And coming out lah, coming out. Pure molten iron here. Okay. So you get iron, molten iron without any impurities there. And then only after that they can add 1%, 2%, because now it's easy. Because when something that is nothing, when something is pure, to make it impure is much easier. Rather than you try and error like this way is better. Because this way is fine for the small scale. Small batch in the lab is okay. But when you want to create this thing at the large scale, you need something, the process that is so easy and repeatable. So the way how they make it is that they jet the oxygen. The oxygen will burn this thing, because oxygen and this hot, it will burn this thing. The oxygen will combine with the carbon dioxide here. And then remember, here the iron oxide, here, this iron here is not molten, it's different from here. Molten iron here is different. So as I said before, the metal iron readily oxidized. This is when here lah. But when it's molten, it's like a molten lah. It's like molten, so you can remove the oxygen very easily. So that's why even though you put in oxygen inside this molten iron is not really what we call bind to the molten iron. This oxygen doesn't really bind with the molten iron, but in fact it's bind with the carbon, the silicon, the magnesium inside this molten iron. So that's the difference lah. So this what we call Bessemer process. They remove all the impurities inside the molten iron, and then after that, only then they add this thing. So that's why they can precisely put 1%, 2%, or 4%, and so on, because of this Bessemer process. Because of this Bessemer process. Any question until now? Any question? Penat? Penat Farah? Letih. So that is basically what make steel is become the industrial material, because of this Bessemer process allow the production of the steel in the large scale. If not, people don't know, oh, is it 2% carbon? Is it 4% carbon? Oh, like that. So because of this Bessemer process, so I just show you Bessemer. Bessemer steel. That bit. You see picture lah. You see, this is the steel. So you can see there. So that is Bessemer converter. So they put this thing. The reason why they do the drawing is like this, like a telur, like an egg, is because they can apa orang kata? Apa ni? You can just roll in whatever they want lah, because remember first they will put the molten iron inside this. They put the molten iron inside this, and then they flow the jet of oxygen here, and then they like that lah, this thing. So that thing. So let's see the real image lah. This is not real image, right? So that thing. So you can see the reason why they do like this is because they can move it here and there lah, here and there. So let's see in the real. Betul ke saya buat ni? Real. Bessemer smelting. Not smelting, but whatever lah. I want to see the picture that's inside this thing. The Bessemer process of making steel. Ni, you see here, this thing? That is the Bessemer thing lah. Okay, so this is not Bessemer, just this thing. You tengok ni copper. You look in the YouTube lah. You ada lah. But basically the idea, you have this thing, and then they put the molten iron inside, and then they flow the air of oxygen here, pure oxygen here, and then the oxygen will bind with all the impurities. The impurities goes out, you get the molten pure iron, and then after that they add the carbon, so you get the steel. So this what make the industry steel become industry material lah. Okay, so this thing is not pure steel. This steel, but it's a stainless steel, meaning that they add something, because steel readily rust lah. Saya ada bawa tak? Saya tak bawa ni. Ni. Okay. So this one is steel. Not stainless steel. This is steel. You can make a steel like this. Okay. This is steel, besi. This is stainless steel. The stainless steel is the one that you see in your kitchen lah. All this kitchenware is normally made from the stainless steel. So in order to transform this to this, you add something. You add chromium. Normally you add chromium. So stainless steel. So I put here. So stainless steel is basically steel plus around 11% chromium, like that. Chromium. Okay. So this chromium, people put chromium is in order to what we call to prevent the corrosion. So this stainless steel, steel plus 11% chromium. I think I can rub this down. Let me rub this down. Okay, I lay this down. So I think I rub this down. So about the stainless steel, normal steel like that, this steel, they rust because of what? Why they rust? Why they rust? Oxygen. Why? So oxygen did what to this? Attack. Macam mana dia attack? Macam mana dia attack? Dia react dengan oxygen, and then form apa? Ferrum oxide. So basically normal steel, for example, you have steel here. Inside the steel, you know there are carbon, right? There are carbon and also there are iron. So let's say there are iron here. There are iron here, and also there are some carbon. There are some carbon here. Okay. When you use steel, normal steel, so in the environment you have this oxygen around you, right? The oxygen will sort of like react with this. As I said, oxygen and metal, especially iron, readily oxide with each other, react with each other. So the steel will react with the oxygen. You get apa? Ferrum O3 2. Macam mana? But you got ferrum oxide lah. Saya tak tahu dia punya ni. Siapa tahu dia punya ni? Equation? The equation ferrum oxide. Ferrum 3 oxide actually. Ferrum 3 oxide. Ferrum 3. What is what we call the oxidation rust equation. Betul tak? Rust equation. So that is rust equation. This is the thing. This rusting. Whatever lah. Process of rusting. Whatever lah. The most important thing that you should know is that you will get the ferrum oxide lah. Ferrum oxide. Okay, ferrum oxide. So this ferrum oxide is basically the one that you see like rust lah, the flaky stuff thing. So the ferrum oxide will sort of like this is flaky stuff, or we call it rust lah, We call it rust lah. Okay, so this rust, because the oxygen attack the surface, because whenever you have something, it will attack the surface first. They cannot go inside. Okay, they attack the surface first. So when they attack the surface, you have a rust here, and the rust is brittle, something like that, and then over time the rust will peel off, exposing another new surface to attack. So the rusting process is like become like cyclic lah. Become once the rust fall down, another oxygen attack the new surface, and then rust appear again, and then rust fall down, and then the oxygen attack again, and the process continue. So that's why rust or corrosion is one of the most problematic issue when people deal with metal lah. Most of the what we call the cost of preventing rust is very high lah, because once rust happen, as I said, it will expose another layer of the new surface, and then it will sort of like compromise the strength of the material itself. Because when the thing flake off, so some of the material will go off lah. So the strength of the original material will be compromised lah over time. So that's why people don't want rust. Okay, but when you add this, when you have something now, let's say you have this thing, you have what we call steel, but then you add some of the what we call some chromium. You add some chromium. Let's say you add some chromium. When the oxygen coming in, the oxygen will react with the chromium first. Okay, before it react with the iron, because rust is basically ferrum oxide or iron oxide. Sorry. Assalamualaikum. Kelas. Nanti ya. Pukul 10. Pukul 10. Okey. Okay, so when you have what we call steel with the chromium inside, the chromium will react with the oxygen first before iron react with the oxygen. So by doing so, it creates some layer. They call it chromium oxide lah. The layer of chromium oxide. This chromium oxide is transparent. And also is attached very dearly to the steel. So this transparent coating, we can call it like a coating, sort of prevent the oxygen coming through inside. Okay, so that's why the steel, stainless steel, this is what we call stainless steel lah. Stainless steel is when the steel is added with the chromium. Let's say this chromium atom, chromium atom, chromium atom. Okay. So here, you see it's not corrosion. There are no corrosion because on the top of this, there are layer of chromium oxide. Okay, you don't see lah, but if you see under the microscope, you can see lah. The layer of chromium oxide, and this chromium oxide prevent the air from coming inside, preventing the, what you call, the oxidation from happen lah. Okay, so that is what we call the stainless steel, the story of the stainless steel. So you learn about steel, you learn about the stainless steel. What else? What else? Sorry? Crystal structure and so on. Okay. So just before we end, I just give you some properties of metal, some generic properties of the metal. So these properties we will discuss in further detail later on after the mid break lah. But one of the properties of the metal is, let me read okay, metal metal ni, the definition of metal itself is basically what is the definition of metal? Is composed of one or more metallic element. Metallic element can be iron, ferrum, or aluminium, gold, and so on lah. So on, whatever, so on. And often also some non-metallic element like carbon, silicon, carbon, nitrogen, oxygen, and so on in relatively small amount. So this is basically the definition of metal lah. It's something that is composed one or more metallic element, okay, iron, aluminium, whatever, and often also have inside it some non-metallic element like this lah, like steel lah. Okay. Metal alloy, when you say metal alloy, is basically it composed one or two metallic element. Okay, metal alloy, this metal alloy is basically when you have material that have the combination of more than one metal element. Okay, like this thing lah, like this alloy lah, steel plus chromium, because you have chromium which is a metal, and also steel have the iron, so we call it alloy lah, alloy there. Okay, and also there is definition. The properties of the metal, some of the properties of the metal is that, I don't know which one. Okay, some properties of the metal is that first, the atom, atom is orderly arranged. We have seen before in the in the picture there. When you look at the metal atom, is arranged very periodically in order. So atom is orderly arranged, and also they can they conduct electricity. They can conduct electricity. The reason why metal can conduct electricity because of this. You have the mobile electron inside the metal, which we will discuss later on lah. And then it also it's opaque. It's opaque. Have you ever seen metal that is transparent? Have you ever seen metal that is transparent? No, right? So metal is opaque. Because remember the properties, when we talk about the properties, properties of material, we talk about 6 things. 1, 2, 3, 4, 5, 6. The first one is mechanical, and then thermal. What else? Electrical. Lagi apa lagi? What else? Deteriorative. What else? Optical, and then magnetic. Magnetic. Okay. So in terms of mechanical, we have discussed before. In terms of mechanical, so this is optical, optical. This is optical. So I put this optical. So I put numbers lah. Optical number 4. Conduct electricity. So it's basically number 3. So metal is also ductile, strong. I put strong. Yet ductile. Ductile meaning that you can bend lah, malleable. So that is the mechanical properties of the metal. So that is number 1. Okay. And then what else? Opaque, and then what? Thermal. It can also conduct heat. It's also conduct heat. So that is number 2. Number 2. And it's also some of the what we call some of the metal have the magnetic properties. Some of the metal, some metal got magnetic properties. For example, nickel, cobalt. Typically, these two, they have magnetic properties inside that. Okay, so that is magnetic is number 5. Number 5. Okay, and 1, 2, 3, 4, 5, 6. Deteriorative is basically the corrosion lah. The number 6 is corrosion thing lah. Susceptible, some metal susceptible to corrosion. Okay, so that is number 6 lah. 6. So this is one the properties of the metal lah. So metal is strong yet ductile. Metal is opaque. Metal can conduct electricity. Metal can conduct heat. Some metal got magnetic properties. For example, nickel, cobalt. What else? I think nickel, cobalt, and nickel, cobalt, ferrum, iron lah, because iron also some. Okay, nickel, cobalt, iron. Some metal also susceptible to corrosion, and yeah, that is the properties of the metal lah. The generic properties of the metal. The reason why some metal got magnetic, some metal is not magnetic, we will discuss later. Okay. So this is the generic, what we call generic idea about what is metal. So I think that's it for today. So today we learn about what? We learn about why the metal is useful. Okay, we learn about the crystal of the metal, the crystal, the dislocation, the crystal, and then we learn about what? Structure of the metal. We learn about this Bessemer process. We learn about the steel, the alloy of the metal when you combine two metallic element together. So we learn different type of steel. Okay. We learn also about this the metal reaction with the oxygen, especially for the steel. Why people add chromium and what make this steel different than stainless steel. So we learn about that, and at the end we learn about this properties, generic properties of the metal. So that's it for metal.